Good afternoon. Today we are going to start a new chapter, that is sequence and series. Do you know the meaning of sequence? Do you know the meaning of series? Okay, we'll see. Some numbers arranged in a definite order, in a definite rule, we can call it as a sequence. So, look at this. Suppose if I am writing a number, a series, number series, 5, 9, 13, 17, like that. So, as you can see, this series is a finite series. Finite series means there should be an end of the series. But if I want to ask you, what will be the next term of the series? As we can see, there this is called first term, second term, third term, fourth term, like that. If I want to ask you, what do you mean by the value of fifth term? So, as you can see, this term 1, T1, we can denote it as A. This is T2, term 2. Like that, if I want to ask you, what is T5, the fifth term? Yes, you are absolutely correct. Easily we can find it by saying that the fifth term will be 21. What will be the sixth term? Sixth term will be definitely 25. But if I want to ask you, children, what do you mean by the value of T100? Suppose then you have to calculate, okay, this is T1, this is T2, this is T3, this is T4, like that. We have to calculate up to 100 terms. So for that, I want to show you some very simple method. What is it? Let's see. Now, as you can see in this question, each term has been made by adding plus 4 with the previous term. 5 plus 4, 9, 9 plus 4, 13, 13 plus 4, 17, like that. This plus 4 is the difference, and the difference is common for each of the terms. That is why it is called common difference. It is called common difference. This common difference is denoted by D. This common difference is denoted by D. Now you can see that if I consider the first term as A, if the first term is A, the second term is made by A plus D, means first term plus 4. The third term is made by second term is A plus D plus 4, that means plus D. So that means we can say it as A plus 2D. Similarly, the fourth term is made by A plus 3D and so on. Now you can see A multiplying something with 0. We are vanishing the term, right? So A can be written as A plus 0 into D. A plus 0 into D. Now as you can see, the first term making as 0 as the coefficient of D. The second term made by 1 as the coefficient of D. The third term made by 2 as the coefficient of D. Now if I want to consider the 100 term, so what will be the coefficient of D? Yes, you are absolutely correct. The coefficient will be 99. That means 1 less the asking term, right? Now, if I want to ask you what is the nth term? Nth term. So what can I write? Nth term as Tn, nth term as Tn, and so on. As we are writing this term, we will definitely write A plus, right? Now, first term is 0D, second term is 1D, third term is 2D. So nth term will be, yes, n minus 1D. So we can write it as n minus 1D. So this is the formula for nth term of an AP series. So as we can see, this is called an AP series, arithmetic progression, where we are adding a particular number to make the new term. So this is called arithmetic series or arithmetic progression. Have you understood, children? Okay. Now, as you can see, if I want to ask you in an AP series, Now, before that, I want to show you something else. You can see, suppose if I am writing a term 2, the next term 6, then the next term 18, then the next term 54. Now, is it looking like the same progression, the same pattern which is following for the previous question? Is it? No. Because here we can see, if you are multiplying a particular number, the next number is negative. Right? So 2 into 3, 6 into 3, 18, 18 into 3, 54, like that. So here we can say this 3, the multiplying constant is common for everyone. It is called, this is called common ratio. This is called common ratio and denoted by R. So as we are considering first term as in the previous, here also we are considering the first term as A. Now, how did I get the second term? A into R, right? For this. So the first term will be A, the next term will be first term into the common ratio. How we make first term into the common ratio into the common ratio? That means we can write it as AR square. Here we can write it as AR cube. Right? Now we can see that here the first term makes A into R to the power what? Here we can see R to the power 1, here we can see R to the power 2, so here nothing is there, means R to the power 0, because something to the power 0 is 1. So first term T1 is making us A into R to the power 0. This by T2 R to the power 1. So 1, term number 1, R power is 0. Term number 2, R power is 1. Term number 3, R power is 2. Like that. If I want to ask you what is Tn or An, then we can say A into R to the power n means 1 less. That means n minus 1. This series is called geometric series, where we are multiplying or dividing a particular constant number for making a new term. Okay? Understood? Okay. Thank you. Now, if I want to ask you a simple basic question from algebra, everyone knows this. What do you mean by A power plus B whole to the power 1? We all know something to the power 1 means that particular number itself. So we can say A plus B. If I want to ask you children, what do you mean by A plus B whole square? So A plus B whole square we can say as A square plus 2AB plus B square, right? Then if I want to ask you what do you mean by A plus B whole cube, that we can say as A cube plus 3A square B plus 3AB square plus B cube, right? Now, up to this we know. Do you know what is the value of this A plus B whole to the power 4? Yes, we didn't learn it, we don't know, but it can be found very easily. If I want to ask you what do you mean by A plus B whole to the power 100, A plus B whole to the power 100, that also we can easily find out. Let's see. Here, how many terms are there in the question? Each are having 2 terms. So these are called binomial, right? So today we are going to learn binomial theorem. Today we are going to learn binomial theorem. Let's see. I want to show you something. Just observe this pattern. First of all, when the power is 1, how many terms are there in the answer? 2. When the power is 2, how many terms are there in the answer? 3. When the power is 3, how many terms are there in the answer? 4. So if I want to ask you A plus B whole to the power 4, the first thing coming from your mind, how many terms will be there in the answer? Yes, n plus 1 means 4 plus 1, 5. So there will be 5 terms, right? Now, if I want to show you something, let's see. As we can see, now observe only the terms, not the coefficient. These numbers are called coefficient. Here the coefficient is 1, here the coefficient is 3, here the coefficient is 3, here the coefficient is 1. Now if I want to show you how this Let's see. Now, here a to the power 1, the first term is a to the power 1, a to the power 2, first term is a to the power 2, a to the power 2, first term is a to the power 2, so definitely here it will become a to the power 4. Right? Now, just observe this. If I want to ask you, hello, what do you mean by something to the power 0? Already we have discussed it, right? Something to the power 0 means 1. So can I write a to the power 4 into b to the power 0? Or a cube into b to the power 0? Yes, we can write. Let's see. A cube b power 0. Now, you see the power of a. It decreases. First it is 3, then it is 2, then it is 1, then it is a to the power 0. Now here you can simply write a to the power 4, the next term will be a to the power 3, then a to the power 2, then a to the power 1, then a to the power 0. Right? Now observe b. It's increasing. Here b power 0, b power 1, b power 2, b power 3, like that. So here b power 0 it will be b power 1 is b. Here b power square, b0, b1, b2, b3, now b4, b to the power 4. I hope you have understood, right? Now, these are the terms. I have written only the terms. I haven't written still what is pending, the coefficients. These are the terms. So, how to find the terms? As you can see, power is 4. Obviously, the highest power will be the highest power, right? The power of the exponent of the binomial will be the highest power. So, we start with 4. That a, then increase, then decrease, then increase, then decrease. Here just increases this. Right? Now we have to write these numbers, these coefficients. How is it? Let's see. If I want to make it here, it's a very easy pattern. We'll write start with 1. Okay? Then we'll write left hand side 1, right hand side 1. Okay? Then this is the term. Then we'll write this side 1, this side 1. And between these two, we'll write the sum of these two. So this sum is 2. So wherever we can see a gap, we'll fill it of the sum of the previous two numbers. So here we can see between these two, one gap is there. We'll write the sum of them. Then again start next time with 1, 1, left side, right side. Now here is a gap. So 2 plus 1, 3. 2 plus 1, 3. Done. Next again start with left side 1, right side 1. So 3 plus 1, 4. 3 plus 3, 6. 3 plus 1, 4. Similarly 1, 1. So 1, 1. So 4 plus 1, 5. 6 plus 4, 10. 6 plus 4, 10. 4 plus 1, 5. Like that we can find out the coefficients of this binomial. This you can see it is making a triangle. This is called Pascal's triangle. This is called Pascal's triangle. Now you can see this is the actually coefficients of the binomial. 1, 2, 1. This is the 1, 2, 1. Next 1, 3, 3, 1. 1, 3, 3, 1. Now 1, 4, 6, 4, 1. Just write it down. 1 more to write. 4, 6, 4, 1. We are done. This is how we can find out a plus b or x plus y to the power anything in the notes. I hope you understood 2 chapters, little bit introduction I have given you. So thank you so much. Have a nice day.